On number 42, we have another word problem. This is a Ferris wheel problem. First thing that I always like to do is draw a graph. It says Sarah is riding a Ferris wheel. Her sister Carrie starts a stopwatch and records some data. Let H represent Sarah's height above the ground at time t. Carrie notices that Sarah is at the highest point 80 feet above the ground at t equals 3 seconds. When t equals 7 seconds, Sarah is at the lowest point 20 feet above the ground. Assume that the height h varies sinusoidally with time t. If half of a cycle took 4 seconds, then it should take another 4 seconds to complete the cycle for the Ferris wheel to get back up to the top. Let's draw in the cosine graph. Now from here, let's identify maximum, midline, minimum, and period. Our maximum is 80. Our minimum is 20. The average between those will be our midline. Add them up, you get a 100. Divide by 2, you get a midline of 50. Our period is the length of one whole cycle. 11 minus 3 seconds is 8 seconds. From there, we can now find A, B, C, and D. That will allow us to write our equation. Our A value, or amplitude, is the difference between the midline and the max, or the midline and the min. Our A value is 80 minus 50, or 30. Our B value is calculated from the period. Remember, 2 pi over B equals the period, in this case 8 seconds. Cross multiply, we get 8b equals 2 pi. Divide both sides by 8, and b is equal to pi over 4. Our C value is our phase shift. That's the horizontal shift. Notice that our graph did not start until t of 3, so our C value is 3. Our D value is our midline, and that represents our vertical translation, and it's equal to 50. In part A of the question, it asks us to write the trigonometric equation for the height h of Sarah above the ground as a function of time t. We can now write that equation. This is a positive cosine graph. We get y equals 30 cosine pi over 4 theta, in this case, minus 3, that's our phase shift, plus 50. Remember, this is based on this equation, A cosine B theta minus C plus D. Now let's answer B and C. What will the height of Sarah be above the ground at t equals 11.5 seconds? This one isn't easy to look up in our data table unless we change the table values and go by 0.5s. That's something that you can do in second table set or second window in table set. The other alternative would be to go to second trace, number 1 value. And when it asks you x equals, put in 11.5. When you do this, it will tell you y equals 77.716 feet. That's correct to 3 decimal places. In part C, it asks us to determine the first 2 times when t is greater than 0, when the height of Sarah above the ground is 70 feet. To do this, go to Y2. Put in 70 feet. When you regraph, you should get a horizontal line at 70 feet. Since it wants us to find the first 2 times, we'll be looking for these 2 points. Use second trace, number 5, intersect to find the intersection. You'll have to do this process 2 separate times. Each time you'll want to go as close to the point of intersection as you can. You'll hit enter 3 times. The first time it goes to the first curve, second time it jumps to the other curve, and the third time it actually finds the point of intersection. When y2 is 70, x will equal 1.929 seconds the first time, and 4.071 seconds the second time.